Okay, so I named this talk the Post-Apocalyptic Unsafe World for a couple of reasons. I'm not sure, somebody might know me from last year's rant about sun.misc.Unsafe being removed from Java 9, or at least hidden. That actually doesn't happen anymore. So we got what we wanted, and I thought, okay, maybe it's time to stop ranting and making some friends with Oracle again. At some point, I might want to get my Java champion before they actually stop the program. So I chose this picture on purpose because I think it shows a nice future. So you see that there's this apocalyptic world, but actually it is going nice again. So let's see what is going to happen here. So that is me. I think everybody knows those kind of slides, right? I'm manager developer relations at Hazelcast. Actually not talking about Hazelcast, as you can see. When you like your Twitter timeline to be totally bursted, you're free to follow me. Otherwise, you probably shouldn't do that. I'm a Java passionist. I'm part of the JCP, the Java community process. Who knows what the JCP does? Wow, perfect. So I don't need to explain. We're creating the Java standard. We're moving the Java standard forward. And just yesterday, we got the JSR, so the specification request for Java 9, which is actually quite interesting and nice. So I know what my weekend will look like. I'll probably read through this JSR. Apart from that, anything related to network protocol, speed, garbage collection, any kind of benchmark fairy tale, because benchmarks are never real. Anything like that is what I'm normally up to. So I put in a disclaimer because when I gave this talk the first time, somebody the day before asked me on Twitter, "Are you going to rant again?" And no, I don't. I don't. I just want to make this make this clear. But, and this is important, some of these things are very speculative. The APIs might change. We see one example where the API just completely recently changed. So don't take anything of that for granted right now, because some of those things, it's basically selling dreams. That's what I'm doing today. So I think we can start here. The people that used on sun.misc.Unsafe already, they probably know that. It's like running with scissors. So I thought what would be a better name to actually name this class, and it's probably sun.misc.Scissors. What you don't, or maybe you know about sun.misc.Unsafe, maybe you don't. So first of all, it is supposed to be an internal class. There is no way to not show this. It's sun.misc for a reason. Sun.misc was always considered to not be externally available, or it shouldn't be at least. So if you look into the class hierarchy, you see that there's a lot of weird stuff like VM support and VM and all this kind of weird things. And it's normally used inside the JVM and the JRE to kind of combine things on the runtime level and in the JVM itself. That is what it is supposed to work for. My favorite example, and I'm happy that Blake just gave his talk about how you should write code and how you should be humble to other people. That is fork join code from Doug Lee. I know everybody, or we all know this claim, like in Duck we trust. If you can figure out what that code does, it's amazing. I just have no idea because he doesn't like to write variables or something. I don't know. So the thing is, well, it's used outside of the JVM itself as well, and for good reasons. For example, to speed up the serialization, but unfortunately also for very, very bad things. At the JVM Language Summit, Mark Reynolds had one amazing thing, and it was awesome. So let's see who can figure out what is wrong here. So somebody tries to free memory using sun.misc.Unsafe, which is okay. It works. That is what it is designed for. The unfortunate thing, he wants to do this on a Java object. So how does that might work? Well, maybe it's the hash code from the object. Maybe it's the object address. Maybe not. Maybe not. The thing that most of the time happens is you end up writing in or trying to free write to a memory space that is not the JVM memory space, and you're not allowed to do that for good reason. I actually made it very easy and very satisfying to get this fail all the time and segfault all the time. You just use set native address, which is sun.misc.Unsafe put int, and you write to the address 0, null pointer. So we've seen some good and some bad things. It was never intended for outside use. I already said that, and there's actually a proof for that. So this goes back to 1998, 89, showing why developers should not write programs that call sun packages. So it basically was never ever meant to do that. Unfortunately, it's still pretty useful, and well, there are a lot of popular libraries using it. And I just created a slide where a couple of things are in. There's Hazelcast. I just don't highlight that because I'm wearing the good branded t-shirt, so I don't need to highlight that. But it's the interesting thing, who uses Netty? Netty, perfect. Some Mockito, EasyMock, JMock, pretty good. Cassandra, we're getting close. Spring, bad. You're basically would all be fucked if Java 9 would hide sun.misc.Unsafe. Some people don't, because sometimes they're like fallback solutions. Most of the time they're not. Well, there's a fallback solution, throwing an arrow, hey, we need sun.misc.Unsafe. So the other claim that a lot of people use to say you're not supposed to use unsafe is it is only available in the hotspot-based JVMs. Who knows that claim? Well, at least one person. Unfortunately, it's not true, and I just walked through some of the JVM implementations I could find. There's even a JavaScript library that unfortunately doesn't have sun.misc.Unsafe. But pretty much everything else, you see the versions, most of them support almost all of the sun.misc.Unsafe features because they're so widely used and useful. So that claim doesn't hold either. Well, so let's look through some of the use cases. I said there are some really good use cases, and one of this is low latency and GC overhead minimization. So we have just a single object, a point class, and this is a flight weight pattern, and it basically just gets the base address and uses sun.misc.Unsafe to read from the object's offset, or in this case from some offset based on the original address. So this is kind of simply overly simplified, but it works that way. So sun.misc.Unsafe gives me the option to write or read directly into specific memory addresses or in objects. Fast deserialization, we already seen that on another slide. I basically use allocate instance, which doesn't execute any constructor. So that is a really interesting thing because it means I can create a Java object without running massively costful or expensive constructors, which normally would happen in the Java serialization. 64-bit memory regions. Who's bugged by 32-bit byte buffers? Okay, at least one person. Pretty good. So sun.misc.Unsafe gives you the option to allocate as much memory as 64-bit can hold, or as long as you have memory in your system. So in theory, I can say, please allocate whatever max value of long is. I can't remember this number. And then you just write to this memory position that. So the thing is, allocate memory gives you the address. Who knows malloc from C++ or C? Well, kind of the same thing. Atomic memory operations. Who needs atomicity? CAS operations? Well, that is what sun.misc.Unsafe gives you. Based on objects, based on addresses, based on pretty much everything you want. So you can really say, or this is actually the internal implementation for all the atomic long, atomic integer, atomic whatever classes. Well, you can just do it without creating any objects. Efficient memory layout. we fortunately will figure that out later. It's kind of fixed already. So who knows how big that object would be in Java? $12, I guess. 32, perfect. For what reason? There's a header and you get the padding. So 32 bytes for just 2 longs. You can just save those as 2 longs. The same way we saw the example before, you have a flyweight pattern and you just read them right through, directly through the memory. Fast field access. How many people are already loose? Okay, field access. As I said, you can write and read to parts of objects. So what I do is I have a field, a Java lang reflect, whatever it is. So normal reflection field, and I say, please give me the offset of this field inside of the actual object. And that means I can use that to read directly the value from the field. I don't need to go through the field. It sometimes makes access to objects or to values way faster because there's no bounding checks, nothing going on. Very interesting. Works with pretty much the same way for arrays though. Yeah, array access, as I said, it works pretty much the same way. For an array, the only interesting thing is the index scale and the base offset, because an array always has this little header which says it has that much elements and stuff. But the interesting thing here is you can do something which is not possible in the Java language. So who knows what happens when you make or when you mark an array as volatile? Well, the interesting thing is it is part of the array, not of the elements. That's the important thing. So when you mark your array as volatile, it doesn't mean that your elements inside of the array are volatile. And you can do exactly that with sun.misc.Unsafe. There is no way to do this in Java right now. So the last thing, memory fences, that goes pretty deep. We just heard about volatility of arrays, and you can actually emit your own memory fences whenever you think it's the right thing to do. Which is nice. You can have a full fence, so a store load barrier. You can only have a store only a load barrier. Oh, there's one more thing. Right. Oh, I forgot about that. Right. Native code. How many people work with things like JNI for unfortunate or fortunate reasons, whatever you like? So have you ever had the problem that you integrated with some native library, C library, C++ library, and you had to give it a memory position to work on something? Yeah, most probably. So that is what sun.misc.Unsafe also gives you. You can just allocate some memory inside of your JVM's process space, and you copy all your data to it, or you've written it directly using a flyweight pattern, and then you just do your native call. The best way to do this at the moment is JNR, by the way. Okay, how do we get access? Who has an idea? Well, there's an easier version, at least if you're inside the JVM. So that is what Oracle and JVM engineers or JRE engineers use. They just use unsafe.getUnsafe. Unfortunately, there's some little test in there that you're part of the bootstrap class loader and blah, blah, blah. So you got the idea. For non-JVM engineers or non-JRE engineers, we have to do it reflectively. And that means there is this magic field, the unsafe, in the unsafe class, which is the single instance of unsafe, and you just access it and get yourself the unsafe instance. Right, because that is the one that is not just working on Android, because on Android it's not called the unsafe, it's the one, for an obvious reason. And there are a couple of more JVMs which doesn't call it the unsafe. So what you do is you just walk through all the static fields in the class and you try to cast it to unsafe, and if you find something, you're good to go. Well, yes. So that is the working one. That works on, I think, every JVM I tried it. It's not a nice one, though. There's a tricky one as well, and I think Charles Nutter actually created that one. And we just get the default constructor of the unsafe class, and we create our own instance. That's neat. I like that. It kind of works against the singleton pattern, but we all know singletons are shit anyways, right? So who cares about singletons? The problem is, does any of that feel right? Beside the first example, and you're inside the JVM, probably not. You're laughing. That was the restroom at our first office in Palo Alto. So my boss actually made this picture and tweeted it, and like, where did you get this from? I made it. Are you kidding me? Well, but that is not better. So the thing is, no, it doesn't feel right. And that is the reason why I totally agree with Oracle and every other person that unsafe has to go away. The features are good, the way it works is shit. And there's no better word to say that. So the thing is, some Oracle engineers were very eagerly and written to some blog posts, some mailing lists. So we see that was April last year, and Donald had made a point here. He said, sun.misc.Unsafe must die in a fire and ignore any kind of theoretical rope. Very good, right? And kill unsafe dead, kill unsafe right. I thought, I've read this once, twice, and I had this feeling like, did Oracle create a new task force? Something like the kill unsafe to total death? I don't know. It felt like. But I read it again, and he actually had a very good point here. And if you're using unsafe, this is the year to explain where the API is broken and to get it right. So that was his important point. He just had a lot of blah around it, and I agree with that at least. So what's coming? Let's go for the interesting things. So we've seen that we can do atomic updates using unsafe. And I simplified it. I just said find unsafe. However that works. So we've seen that we have a compare and swap, we have a version offset, and we have a version, and we try to increase it. If it doesn't work, compare and swap works. I think compare and swap, you know how it works? You give it the old value, you give it the new value, and it will atomically exchange it if the old value is still the truth. So this might fail, and then you just retry. If you have a very low contention rate, this is very, very good, because first of all, you never lock, and secondly, the thread will not be switched out of the context. So we can do this today. We have atomic long. I think everybody knows atomic long. All right. What is the problem with that? Perfect. So we have one object. For example, imagine this is a data record, and you create a version field for every data record. Well, now we don't have one field, but not one object, but two. Okay, there's a better version. You can make it a static final field updater, which goes a bit deeper. So now we have just one static final instance of this field updater, and we're doing pretty much the same thing. That means now you have 100 records and just one updater. That's better. What is coming with Java somewhere? It was expected to come in Java 9. At least that was what Oracle was thinking. I was never actually true. I would never believe that. Oh, by the way, there's in all of those examples, there's one important thing. We heard about making nice code comments. So your IDE will never see that this field is updated because it's not updated through Java code. So please be nice to your colleagues and make a comment like, hey, your IDE is basically wrong here. I know what I'm doing. That's the good thing, right? We learned about that you have to know what you're doing, but you have to tell others. So what is new here is the so-called VarHandle. And I think that some people worked with method handles maybe already? Method handles? Well, you too, okay. So method handles are an intrinsifiable or what is the word? Not intrinsify. Inlineable method call. Yeah, it's a two-step linking, but I'm trying to make it easy. So basically imagine it as a reflective call that the JVM is able to inline as it would be a normal call right inside your bytecode. So VarHandles going the same way. Those are inlineable, variable, field, whatever accesses that the JVM can actually handle the same way as you would write it directly in your Java code. The good thing is it doesn't create any overhead once the JVM inlined it. If you look at the code, how this stuff is implemented, it's actually quite interesting. There's always this always inline or inline annotation, whatever it's called. So this really inlines down to the absolute call itself or to the access itself. So the second thing, memory access, 64-bit, good old times. We've seen that, right? Allocate memory. Well, in this case, I don't need 64-bit, but I'm just doing it because it's nice. We can do this with byte buffers. We just have the problem, byte buffers are just 32-bit because the API is, for whatever reason. I'm not saying that Mark did a great job creating this API, because when he created it, 64-bit was already a thing, at least in companies like outside Sun maybe. I think that was still Sun time, so it's fair to say it seems to be outside Sun. So we have this problem with 32-bit. We stuck with that, and the new way is, there's a slightly better thing, again, for the VarHandle. So now you can allocate again the VarHandle, the byte buffer. But what is important here is this method handles byte buffer view VarHandle. Oh man. So what I basically do is I say, this byte buffer, please make it look like it would be a long array. And I don't care how you do that, but I'll afterwards use it like that. So I have this byte buffer, and I want to have the max value of long written into the first index of this virtual array, whatever this array looks like internally. And I do it the same way with getLong. I can... What? Okay, so the other idea was to get around this 32-bit problem, creating memory regions. A memory region could have been everything, like everything straight up to 64-bit. And at that point, when I created this slide, this API was not even in some form written down. So I completely made up this thing just from discussions between Paul Sanders and me. So that looks nice. You have a memory region, and you say, I want to have unaligned memory, so I don't want to have padding, and you give it a size and a name, and for whatever the name is, I thought it was maybe for JMax, like a JVM heap name, whatever. And you can just use it the same way. You create a memory region view that looks like an array. Unfortunately, it's not as easy. It could be easier, probably. That is what actually came out of that. And I still like that. So you have an auto-closable scope. That's nice. So you can have multiple allocations put into the same scope, and auto-closable or this try with resource makes sure that all of the allocations are automatically deallocated whenever you lose the scope. And then there is something I really like, and I've never expected that to happen in Java. There is a class called pointer. Pointer! Now we get the chance to get a real null pointer. And this class exists, I think, inside the pointer class. I think there is a field, a static version of the pointer, which is a null pointer. It just points to address null, or a 0. Very nice. And you use the scope to allocate something, and you say, okay, please create a layout from, I think it's wrong, it should be a long array class. And the same thing, or the same way as we had with the VarHandle, I just say, hey, please create this layout and a long array layout inside this scope, and please use those numbers of elements. That means I see I have a long element, long array. As I said, I think it's wrong. It should be long array dot class. And I say I want to have 10 elements, so the JVM figures out, I need 8 bytes per element. 10 elements means I have to allocate at least 80 bytes. And then you get this offset, and you also get a reference. So we're back to Java, right? Java only has references. So it's actually quite interesting. We're having a pointer asking for an offset inside from this pointer on, and then we dereference it. It looks a bit like C code or C++. And then we work with that. I actually like this API. It's probably nothing that everybody would use every day. Not yet. Not yet. The question was, is boxing and auto-boxing removed? Not at the moment. We're seeing another feature upcoming, and that will actually fix this issue. And I said those are constantly changing. So that was very, very recently. I think it was last week, 2 weeks ago. 2 weeks, whatever. So as I said, those things are constantly changing. So the last 3 slides were just introduced. Going back to deserialization, we can do amazing things. So we read chars from an underlying byte stream, whatever this byte stream is, could be a socket stream, whatever. And we want to put this into a string. Now, there is a constructor that takes the char array and creates your string out of that. The problem is the char array will be copied. It's okay if you would use this char array afterwards somewhere. Unfortunately, that doesn't happen in deserialization. I just create it, I read it, and I throw it in the string, and I will never expose it somewhere else. So this defense copying doesn't make sense. So you create an instance. I already said this doesn't call the constructor, and then you just use object volatile to have the strong barrier in this case, and you set it into the offset of the value field where it actually holds the char array inside the strings. That probably doesn't work with Java 9 anymore because the char array was now exchanged to a byte array for this compact string representation. They're just making things complicated. Probably they're just making it up to make it hard for us. Yeah. So another deserialization, and that is what is also possible at the moment. There's this reflection factory, and reflection factory can create a constructor that doesn't exist in the bytecode, that doesn't do anything. So it basically creates an additional default constructor that doesn't do anything magically. This class already exists. It's in sun.misc. The interesting thing is they're really thinking about making this a public API. So that would solve the problem with this allocate instance because we don't have to use that anymore. And then you just use the constructor like anything else. If you unreflect this into a method handle, it will actually inline. So combining a couple of the nice features in Java or in low-level features in Java will actually help you making this even better. And we also had interoperability, so working with C and C++ code. I think everybody who worked with JNI actually knows that and probably hates it. We had a couple of people. I see only people nodding. Yeah. I actually chose a very simple example, and it still is like, you see, well, nobody wants to think about that. So process identifier, you just load this library because it's process identifier.a.so, whatever. And then you have this native void talk, which actually binds this method to the underlying talk. I actually have a problem here. It should be get process ID. I think I had a different example before. So this method name must have to match up, or get PIDs actually. So you can do better. There, as I said, there is JNR, the Java native runtime, also written by Charles Nutter, the guy behind JRuby. And he created a library loader, and you just have an interface and say, hey, please create me a native implementation of this interface at runtime. What they do is they spin up some magic assembler code at runtime, inject it into the JVM process, and actually execute it. That's pretty neat, and well, it works well. It's the fastest non-JNI version that you can have without actually writing any ugly JNI code. So they did all the magic for you. Kind of the same idea goes for Project Panama. So Project Panama, well, 10 minutes, wow. Project Panama is again Charles Nutter plus a couple of people, and they want to move this JNR into Java itself. They slightly change it, and it will again go back to the method handle API. But method handles now have a find native, and it works pretty much the same way. It spins up the assembler code to bind the native DLL or static object, whatever it is, at runtime, and then you can just invoke it. Well, you solved this very specific problem. I think there are some other things people ask for in C besides process ID. But yeah, so there is a process API coming up in Java 9 that will solve that very problem without any magic. And there we go, value types. Who heard about value types? Well, a couple of people at least. That's nice. So value types are, how did Brian always said, it programs like a class but behaves like an int. So, or the other way around. That is the idea. So you work against a value class like it would be any kind of Java object, but what actually happens is it behaves like a primitive type of the JVM itself. So you can imagine this object to be represented as some kind of a two-element array. That means you get a very narrow data representation, and the best thing, it will be allocated on the stack. So that is the important thing. That means Java finally gets, at least besides escape analysis, some kind of user-developed stack allocation or user-intended stack allocation, which is nice because that means if you would have this point element, you would have to move it to the heap. There is no other way in Java. Besides, the JVM figures out this element or this object will never leave my method, and then I can do the same trick automatically at runtime right now. So this is awesome. Who waited for stack allocation in Java? Only a few people. I expected to see more hands, to be honest. Okay, the next thing, and I really have to speed up. Specialized generics. Who waited for that? You know what that means? Probably not yet. So there is some kind of a new generic stuff coming up. Specialized generics. Specialized generics work some kind of a template. So you're not creating actual classes anymore, but you're creating a template that will be specialized at runtime. And what this actually does is you can create objects with primitive generics, right? Who waited for now? Again, who waited for that? Primitive object, perfect. That is what I expected. So what it does at runtime, it will just spin 3 different classes showing or representing the different versions inside the JVM. So it actually is loaded as 3 different classes as well. So that means if I have an array of T inside my class, it will, and I initiate it with int, it will actually create an int array from the template. And that is awesome. That is what I think all of Java, the Java world actually waited for since we got generics. So you can do those kinds of things. Just again, I think that is now clear, right? As I said, it creates the internal values, and there is no boxing going on anymore because that is fully specialized. That is the important thing. So another couple of things, Arrays 2.0, who heard about that? Brian spoke about it quite extensively. First of all, who figures out what is wrong, weird in this line? We just need to be fast, and I have some t-shirts. Perfect, 64-bit array. Medium? Give it to someone. Oh, there you go. You probably want a large one, right? So, right, 64-bit arrays. So far, you can only create arrays up to 32-bit or int max. The second thing is shop, arrays shop. that actually can shrink down an array. Okay, that's nice. I don't know why is this only going downwards, but for whatever reason. Probably because they just reclaim the non-used memory anymore. I'm actually not sure about that. Well, who knows what that is, why that is nice? No idea? Never tried that? Creating a generified array? What does your IDE or even the JVM tells you about that? Arrays are... Right, arrays don't have generics because there's type erasure. You probably don't know what you're doing. With specialization, that actually works because box string is actually a true type. So you can do the same thing here. Frozen arrays. Who waited for the way to freeze an array that people can't modify it anymore? Immutable types. Awesome, right? And again, together with value types, it's not visible, but this is the point value class we just created a couple of slides ago. You get this very nice data representation because everything is allocated right where you want it to belong to. So that is also absolutely new. I think that came up on Monday. The Cleaner API. Who knows the Cleaner API? You should probably, because you're most probably are using it since Java 1.4. The Cleaner API is an implementation detail of the direct byte buffer. That is actually what makes sure that the direct byte buffer is deallocated when it goes out of scope and finalization kicks in, blah, 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 blah. It's a phantom reference, so whenever the deallocator instance becomes a phantom reference, it will be actually executed, and the claimed memory from the direct byte buffer will be released. What is upcoming is the publicization of this API. So I can now create my own auto-closable, right? Auto-closable. And I have my own state, and the state stores somehow the cleaning action and whatever is necessary, for example, the address and the size. And then I allocate my own memory, or I use the pointer, and I give the pointer in and register the cleaner, and magically it will be automagically cleaned. And the good thing is the cleanable that is coming out of the registration actually takes care that the clean operation is only executed once. That means if my auto-closable kicks in before the finalization kicks in, it will close it, it will clean it up, and even if finalizer comes afterwards, it doesn't matter anymore. So that is, by the way, the only way in Java, or it will be the only way in Java to have real deallocation. Class dynamic, just quickly, templating function. Who worked with aspect-oriented programming? Okay, some people. Templating function, dynamic classes, you just give it a template and you say, well, when for example, synchronized map, every method in synchronized map is just synchronized. So your template is very easy. You have the method, you put a synchronized block, and you call the underlying method. So that will just automatically create an implementation that is completely synchronized from every method. Same goes for logging. I think that is more what people know from aspect-oriented programming. You just want to log every method entry and exit, and the JVM will just create from the template the actual implementation that does that for you at runtime. No aspect-oriented programming framework used anymore. Spin wait loops. You probably can talk about that. I think you actually worked on this as well, right? Okay, so spin wait, if you have a spinning loop, some of the CPUs actually have an opcode making this more efficient. And Azul, thanks to that, made it possible that we get a spin wait that is just an intrinsic to call this opcode on the CPU if it's supported. Otherwise, it's just a no op and will do the busy spin. But that will make spin operations way better. What else? Well, no idea yet. As I said, there's a lot of stuff changing. We've seen 2 examples of just very, very recently changed things. And don't forget to test the early access build of Java 9 because of Jigsaw is merged in. For us, it broke like the very basic things. Class not found exceptions, Java lang string. It's not always about sun.misc.Unsafe. Sun.misc.Unsafe probably would work. We probably find that class, but there's, through the module system, there is so many changes. If you write software, download the Jigsaw-enabled JDK early access builds and test it. Make a compatibility build. Yeah, so basically every of the actual things. And, well, yep, perfect, right? That's exactly. So I still have some t-shirts. I think you wanted the large one. Okay, I have 2 medium and 1 small. So let's exchange that one.
Okay, and we do have time for any questions, so feel free to stick your hands up if you've got any questions.
And the small one. Just hand it over.
All right. So we got time for questions, Christoph, if you want to pick.
Okay.
Any questions? Sure.
Time for questions. Oh my goodness.
It's not a question, Rick. Actually, it's, it's a shameless plug. I'm giving tomorrow a Java 9 talk, which will cover some other areas which Christoph didn't cover. So feel free to come over there tomorrow, or catch me in the hallway if you want to chat about it earlier.
So he's talking about what is actually possible. I was just selling dreams.
Okay, anyone else?
So, by the way, here are all the proposals, some of the implementation details, some of the existing JAPs. Just feel free to read through all of that, or just download the slides afterwards and get the same ideas. All right.